First, hi everyone. I'm very happy to be here meeting with new people in the San Francisco data community. So as Zori said, I'm Claire. I'm the co-founder of Now Labs, and we're building an open source analytics agent. So yeah, just if you want to check out our repo, it's called GetNow. And basically it lets you build the context for your agent and deploy your UI on top of it so that everyone in your company can chat with the data. And maybe to tell you a bit more like how it started. Okay, so how it started is like you probably all want to set up like analytics agents internally. Probably most of you have already experimented with trying some, building some. And the thing I did in January back when we were thinking about that is just like testing all the agents that were available in the market. And for now, I tested 21 different AI analytics solutions, from the BI tools to the warehouse tools to like general tools like Claude or things like that, or like the new startups of the text-to-SQL. So there's a lot of tools. And what I also try to do with this very ugly table is to summarize like the different context options that these tools let you put into your agent. Because in the end, like every of these tools wants you to build AI agents for data, but what does it actually mean to build a good AI agent for data? That's a question we all ask. Like everyone tells us you should build your semantic layer. That's the only reliable way to do AI agents. But like, what's your own answer? Like, how can you prove it? That's not be proven by anyone, I think. Should you put the joins in the context? Should you put existing dashboards? Like everything is just unanswered questions. And so what I tried to do is to find out the answers myself. So basically what I wanted to do is to roll out an agent internally and check what was the reliability of the agent depending on what I put on the context of the agent. So yeah. So how does it work? What I did is I set up a simple agent, and then I created a bunch of unit tests of text-to-SQL. So like I created a data set of 40 questions with the expected answer. So like basically the SQL that I, as a data people, would have written. And then I sent all the questions to the agent with different kinds of contests to check which one had the most impact. So the first thing I wanted to test actually was, I think the first setup we all do when we want to test like AI agents is to just have Claude or any coding agent with your MCP. That works well actually, because like the agent can search a lot of things and has access to the data. So I wanted to check the difference between just having an agent plus an MCP or an agent plus some context preloaded somewhere, and then just the MCP to execute the final query. So you can see here what I did is that I compared different KPIs, because we talk a lot about like the reliability of the agent, but there's also the cost that we need to measure, because if you roll this out, this is going to be really costly. The cost in terms of LLM and in terms of the queries that are going to be run against your warehouse. And then finally, the duration, because you don't want your users to wait for too long before they have an agent answer. So for my first step, what I found is that if I had like just the MCP plugged to the agent and only 17% questions that are right, that's actually very low. I think I realized like many data teams just try this, and I think we don't realize how not reliable this is, or not how non-precise this is, because as data people, we're able to challenge the answers. So we course correct the agent. But if we have to give this to anyone in the company, like these numbers are quite frightening, I think. And if you look at the second, so this bar here is having your agents with at least the list of tables available. So this way it doesn't have to do a lot of MCP tool calls to find out what are the tables available. And you can see it's having a higher reliability, but then it becomes very costly because you send some context in the window of your agents. So it's kind of a trade-off of like, okay, do you want to give it more context so that it's more reliable? But that is going to be more costly. But it's going to do less query because it doesn't have to do queries to discover the data. And it's actually more long because it could go until the end of the answers. I was kind of confused by like why is it longer? But it's because like it didn't like just give up. So yeah, so that's the first thing that made me go into the track to, okay, This means that if you build more context to your agent, then your agent is going to be more reliable. And then we need to tackle like, how do you make it less costly? One, and also like 25% reliability is still not enough. So we need to do more reliability. And then the second thing I did was to add some pieces of context and see what was the impact on the agent. Yeah, so here what I did was really, I didn't want to change anything of my data model because the experience I wanted to do was like, I'm a data team. I don't want to build extra stuff to like re-go into my DBT modeling. I just want to know like with what I have, what is the most relevant. So I started with like just no context. So that was like 17% reliability. With the schema, you add a bit. It's kind of like adding gradually. Adding a sample of your data gets you a bit further into reliability. Profiling as well. So like giving some values, example values of columns gives more reliability. And finally, like the real bump that I got into reliability was creating like business rules for my agent to actually explain to the agent not only what was available, but where it should look at. So basically in the rules, what I put is the list of the main, the most important table, the most important fields, also the definitions of the metrics, and which table was the source of truth for each metrics. So at this point, the agent was like 45% reliable with no building extra, just like me having like an agent writing some extra rules and automatically pulling the context of like the schema of my tables, etc. In terms of costs, you can see also that it really decreased the cost of my agent just because with the rules, the agent knew straight away like where to go find the data. So it didn't have to do a lot of tool calls to discover what was available, but it could just do like right away the querying. And it was also way faster, so like 15 minutes instead of like 20 more. So yeah, so that was the first thing. I also wanted to get the final word on like the semantic layer issue because everyone's talking about semantic layer. I'm way too lazy to have a semantic layer. So the experiment I did here was I generated semantic layer with metric flow of DBT. And then I run my agent only with a DBT MCP with the semantic layer. So it could only query the data on the semantic layer. And so what happens then is that I just can't answer any question. So yeah, there's like 4% questions right, 82% with no answer, and like a few are wrong. So I guess it does the job that it promises, which is less wrong answers, but like it's very frustrating too. But so yeah, disclaimer, I didn't spend any time building the semantic layer. I just wanted to like be in the shoes of like your data team. You don't have time to build extra things on top of what you have. So yeah, this is the result I have for now. But if I go back to the best result I had here is 45% reliability. And you don't want to give an agent that is only one out of two times right to your business stakeholders. So then that's the next work I did. Basically, like when I was at like 45% reliability, I wanted to understand what were the failures of the agents. And I looked at the log of like what was going wrong and try to improve that. So the first thing that I did is, I mean, one big mistake was actually like the agent had really bad time like selecting the date scopes. That could seem very minor, but like for example, if you say what was like churn rate in the last 8 weeks, well, one time it's going to take Monday to Sunday, one time is going to take Sunday to whatever, and then you're on Wednesday, it's going to take like Wednesday to Wednesday. So that's not very like a mistake, but I think that's going to create instability for your users. And then that's going to diminish the trust that they have in your agents. So here, what I did is just basically being very clear on the rules of like, okay, how do you select the date time? If the user doesn't precise where is the date scope, what should you take, etc. And then, so finally, the most impact I had was just like rewriting my data model, because what I realized in the failure that I got is that sometimes the agent picked a random like metric definition because my own data model was rigorous. So for example, like for the churn, I mean, not churn, like, so for example, paying users, like we have people that buy licenses, and then we have people who activate licenses, and that could be two different things. And in my table, it was the same thing. So like the definition was not very clear even for me. So in the end, like what actually got me from 45% to 86% was just actually looking into the ambiguity of my model, of my data model, and fixing that. And, and yeah, so I think in the end, like the most important thing that we get back to is like having a clean data model for your agent to work. And then, so my end reliability was at 86%. And when I look at the failure, like the remaining failure, I would say were kind of like interpretation failure. So for example, I have a question which is like, which percentage of users use this kind of feature? And the agent sometimes would take the baseline as signed up users, sometimes would take as like active users. So I think this is something that can be course corrected by the users. And yeah, and that the agent can also make explicit what they're taking as a context. And also, I don't want to overfit the agent to the unit test that I've built. So I thought that's where I would start. I would stop. And once again, when I improved the data model of my agent, the cost of the LM kept going down. So yeah, so if I summarize everything that I found, like what I recommend data teams now is that I think you can do a first good setup by just pulling automatically some context of your data, your schema, what's inside your data, and then adding in your like rules or like MD files, some business context and business understanding to give a bit more priority to the agent of like where to look at. And I think that's giving you a first baseline. And then, well, you will have to go into the failures and understand why your data model is failing for the agents. And maybe last thing, because I don't want to be too mean to the semantic layer people. Well, I was kind of sad that the semantic layer was doing so bad. So I thought I would like give it a better try. This is still ongoing. I'm still like doing my experiments here, but basically what I realized is that I had just like vibe coded this semantic layer, and I think it requires a deeper understanding of like how the semantic layer works and yeah, which entity measures you need to create so that it works. So what I did is I got back to this DBT MCP setup, looked at the failures and like integrated the metrics one by one. So for now, the best that I have is like 47% reliability. Well, after like adding manually all the metrics. So in the end, I think it could be working. I'm still not convinced that you need to do it if you have, let's say, a medium-sized data model. But yeah, I think it's a trade-off of how much errors you're willing to accept at your company level compared to like the time you're willing to put into setting up the agents. And also one thing that I can't really resolve with the DBT MCP is that it's very costly. Like the cost of my like less costly run is $4 compared to like $2 for the others. So that's way too costly, and it's also like way too slow. Like it's like at least 20 minutes, but yeah, at first it was very long. So yeah, I think TBD on the semantic layer. Maybe the other tools that are better, but yeah, and so I think that's kind of my findings. And I think the goal here, and also maybe going back to why we built now, is that this is an open source framework. I think today we hear a lot of thoughts about like what's a good AI agent, what's a good context for your agents. I think like the AI agents tool force you into their own context framework. And I'm kind of like convinced that the right context for you will be different than another data team. And that's why we open source this framework, is because we wish everyone will do this same analysis and tell us like, okay, I have, I don't know, like 20 tables, and this is what's best for my context. I have 100 tables, and this is what's best for me. And I think by sharing all of our experiments and learnings, then we can actually understand together like what's a good AI data agent. So yeah, I think that was all for me. Yeah.
What did you do to your data model? I think it was the previous slide you had.
What did I do? I think it's mainly one thing was that I was asking the agent to guess some columns. So, for example, deriving, okay, let's say like there's a column with a status, like live or churn, whatever. And I was asking the agent to find out this. And adding a colon, which is like a flag of like is active, is turned, was making it way more reliable. And also something I kind of realized is that you should not model the same for people or agents. Like you're never going to give to a human a table with like 1,000 columns because like could not go until the end of this. We used to optimize for readability, and now I think we should optimize for precision. So now you could like do a data model with 1,000 columns. I think it's going to be better for your agents because it's going to find it. Yeah. So yeah, this and also like some metrics could be computed from different tables and did not exactly return the same like numbers. So yeah, this kind of things. Yeah.
How complex are your questions?
Depends. I did some questions which were quite straightforward, like, I don't know, like last month's MRRs, these kind of things. I've done some more complex questions, which are like, okay, what is the distribution of message send when people are doing this? So like, if I speak SQL language, it was from like, select group by to two cities with joins, etc. Because I didn't want to test only like the reval question, but also like the deeper analysis questions, which I think are harder to solve with like a semantic layer, for example.